Hi, Luke Kane. Welcome back to Algebra 2. Today we're going to talk about solving systems of linear equations by substitution. Now, as you recall, we started out with a problem. We went to Germany for Oktoberfest, but unfortunately we didn't know what the price of ale or the price of lager was. So we wrote this up as a word problem, and then the word problem we were able to translate into a system of linear equations, two equations and two unknowns. And we plotted those two systems. We plotted this system of equation, and we got two lines, one for each equation, and the point in which they intersected turned out to be the only point, the only x and y that would solve both equations. However, we discovered that graphing systems of linear equations is not the optimal way to solve these kinds of systems. In fact, it really only works for 2x2 systems. For 3x3 systems, it can be graphed, but it's really not practical, and it's just not possible for anything bigger. So, today we're going to try something a little more analytic as opposed to geometrical. We're going to try and solve this directly. And we're going to do it by a technique called substitution. Now, I know there's a song that was popular a couple of years ago called Substitution. And while I'm not exactly sure what the song is about, if you look at the video, there's actually a clue in there about how to solve systems of linear equations. See if you can spot the clue. Did you see the hint in the video that will help us to solve systems of linear equations by substitution? Well, what game were the ladies playing? They were playing musical chairs. And as we know, the object of musical chairs is everybody walks around the chairs until the music stops, and then everybody tries to sit down, and whoever is left standing, they get eliminated. We remove a chair, do the process over again. We eliminate a chair each round, and we eliminate a player each round until we're left with one chair and two people, and ultimately we're left with one chair and one person, and that's the winner. Well, turns out solving systems of linear equations by substitution works in a very similar way. What we're going to do is we're going to take a system of equations with m variables, whatever m is, usually something more than 2. And we're going to eliminate variables by substitution until we're down to one variable in one equation. And we know from Algebra 1 that if we have one equation with one variable, we can solve it if in fact there is a solution. So let's demonstrate that with our Oktoberfest problem. Remember, here's our Oktoberfest problem. This is equation 1 and this is equation 2. So we have a really simple set of equations. 2x2 system. What we want to do is we want to eliminate a variable by substitution. Now, since I've done this before, I know beforehand that I'm going to have to do some division. And basically I have a choice. I can divide by 6, I can divide by 4, I can divide by 2, or I can divide by 4. Well, if I have a choice, I'd rather divide by 2. So I'm going to pick this variable from this equation, and I'm going to end up substituting its equivalent into that equation. We'll see what I mean in just a second. So let me copy equation 2. So equation 2 is 2x plus 4y equals 32. Okay, since my objective is to substitute, I want to solve this equation in terms of x. In other words, I want x on the left-hand side all by itself with a coefficient of 1, and everything else I want on the right-hand side. So let me move the 4y by subtracting 4y from both sides. And this leaves me with 2x, that's 0, so that goes away, equals minus 4y plus 32. I want to divide by 2 because I want a coefficient of 1. And if I divide one side by 2, of course I have to do both sides. 2 divided by 2 is 1. 1 times x is x, which is precisely what I want. And this becomes minus 4/2 y plus 32 divided by 2. I can simplify that. That's minus 2y plus 16. Okay, so I now have solved this in terms of x. I now want to plug it into equation number 1. Equation number 1 is 6x plus 4y equals 48. So what I'm going to do is I'm going to take the equivalent of x and substitute it for that x value. In other words, I'm going to substitute this value on the right-hand side for this x. So instead of it being 6 times x, it's going to be 6 times the quantity minus 2y plus 16. I have now substituted minus 2y plus 16 for that x. And now I just copy the rest of the equation. Plus 4y equals 48. And look at this. I have one equation and one unknown. And I know from Algebra 1, if there is a solution, I can solve this. So let's solve this. So we're going to distribute the 6. 6 times minus 2y is minus 12y. 6 times 16 is 96. And now I copy the rest of the equation. Plus 4y equals 48. Alright, I've got two similar terms. Let me combine them. Minus 12y plus 4y. That's going to be minus 8y. Plus 96 is going to equal 48. Alright, let's subtract 96. Remember, we're solving for y, so everything else goes over here. And we've done this many times. So now I get minus 8y. That goes away because it's 0. 48 minus 96 is minus 48. I'm going to divide both sides by minus 8. That becomes 1. 1 times y. It's just y. Minus divided by minus is plus. We don't need it, but we'll put it in there anyway. Oops, we don't need that either, because it turns out 48 is a factor. 8 is a factor of 48. 48 divided by 8 is 6. So now what I'm going to do is I'm going to substitute that y equals 6 in either one of my equations. Well, I'm going to have to multiply it by 4, so that doesn't... but here I multiply it by 2, here I multiply 6. So I'm going to pick equation number 2. I'm going to substitute that in again. I'm going to substitute for y. So this is my second substitution for those who are keeping score. So it's 2x plus 4y equals 32. Number 2. 2x plus 4y equals 32. Same thing. I'm going to substitute again. Now I'm going to substitute for that y. And I'm going to be left with 2x plus 4 times 6, because y equals 6, equals 32. 2x plus 4 6s are 24. That equals 32. Subtract 24 from both sides, and I am left with 2x, goes away. 32 minus 24 is 8. Divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. 8 divided by 2 is 4. So now I have the solution for 6. Now, I would check this solution to make sure it's right. But we've already done this. We've already solved this equation. Remember we did this graphically? We ended up with that solution where x equals 4 and y equals 6. So we have the right solution. Aha! 4, 6. And we found this by substitution. Okay, what did we learn today? Well, we learned how to solve a 2x2 system of equations by substitution. And we learned that it's like musical chairs. The object of the technique is to eliminate variables by substituting in their equivalents. And we end up eventually like, the two people vying for one seat. We end up with one equation and one known. And once we get one equation and one known, we solve for whatever variable is left over. And then we plug in the value of that variable into either of the two equations that are left that we have, and we solve for the second variable. So we've solved for both equations, and we've solved both variables. Now, we can actually reduce this to an algorithm, which means we could have a machine actually do this program. The first step is to pick a variable for substitution out of either of the two equations. And, we pick one where the division is going to be easy, basically. We solve the equation for the given variable. So we solved equation number 2 in our system for x. X equals, and y and something else is on the other right-hand side. Then we substituted in that something else on the other side, y plus something, into the other equation for its x. So we ended up with one equation and one unknown. That means we could solve for that variable. So we solved for that variable. Then whatever we got for the answer for that variable, we plugged it into either equation. And we're left again with one equation and one unknown. Again, algebra 1, solve it, it's no big deal. And of course, we've solved the remaining variables. We've solved the 2x2 equations. And the beauty of mathematics is we can actually check to see if our solution is correct. Next time, we're going to look at a somewhat more difficult problem to solve a 3x3 system by substitution. Thanks for listening. See you next time. Bye now.